Okay, now we are now on example number 4. You can see this. This is a simply supported beam having a point load of 5 kilonewton. This is moment. Don't forget the unit of moment is kilonewton meter. So which is 25 kilonewton meter. And this is a what? Uniformly distributed load of 4 what? 4 kilonewton per watt meter. And the length it covers is 2 meter. And from here to here is 1 meter. From here to here is what? 1 meter. The total length of the beam is nothing but what? 4. For you to solve this, the first thing you need to do is you convert this to a point load, and you notice the uniform distributed load it will act at what? The center of the what? Length that it covers. So now this is nothing but for you to get the point load of this. This one is just like a rectangle, and the area of a rectangle is what? Length times what? Breadth, which is what? 2 times 4, which is what? 8 kilonewton. You get that? So now I've converted to a point load now. So now the next thing is for me to draw my free body diagram. So sorry, I'm coming. Just a sketch. Yeah. Please, when you want to do this, you draw it very neat with your ruler and everything. Then very neat. Okay, this is a pin support. It's going to have 2 reactions. So which is vertical reaction at A, horizontal reaction at A. Here we are going to have 5 kilonewton covering a distance of what? 1 meter. And we are going to have our moment, which is 25 newton meter. And it's covering it's also covering 1 meter. So the distance from here to here is 1 meter. And don't forget, from here to here is okay, this one is going to have just a vertical reaction. Let's say this one is B, arrow B. So we have to calculate the reaction at the support arrow A, arrow B, and what? HA. So after you convert this one to a point, it's going to act at half of the length that it covers. So this one is 8 newton per meter, and it's going to act at what? Half. And don't forget, this one is from here to here is 2, so it's going to be what? 1 and 1. So this is 1 meter, 1 meter. You get that? So now the next thing is for us to calculate the 3 things. We'll always calculate sum of vertical forces, sum of horizontal forces, and we take our moment at any point that we want. Okay, so now let's go. Summation of vertical forces equals to 0, and which vertical force? I told you, you take your coordinates, maybe like this should be positive, and this one is HA, so it means that HA is equals to what? 0. So now the next thing is to take sum of what? Sum of vertical force. This one is sum of horizontal force. So sum of vertical force should be equals to what? 0. So we said the upward force will be what? Positive. That's our coordinate. So now our upward force is arrow A plus arrow B, which is equals to what? Sorry, arrow A plus arrow B, and we're also having downward forces here, and which are what? -5 minus 8, which is equals to what? 0. So it means arrow A plus arrow B will be equals to I think minus 5 minus 8 is nothing but what? Minus 13. So when it crosses, it's going to be what? It's going to be what? 13. So equation what? Equation 1. I hope we get this. Okay. Now you may want to ask that why is it that we do not have write this here? This one is moment, not force. Do you get that? So now the next thing is to take our moment. We take our moment about what? Point A, which is what? Clockwise moment. Clockwise moment to be positive about point what? A, which is equals to what? 0. So now this is my point A now. So we are going to have what? 1, 2, 3, and what? 4. Please, anytime you have moment, anytime you want to consider your moment, don't consider distance. You know, moment is already force times perpendicular distance, so they have already given your moment here. You don't need to consider the distance, you only consider the distance for force. Do you get that? Okay, so now we are having how many forces here? 1, 2, 3. Let's consider our forces first. So our force, this downward force, is going to give me what? Is going to be what? Positive, because it's going to move what? Clockwise, and clockwise here is what? Positive. So this one too is positive, while this one will be what? Negative. But our moment, is this one clockwise or anti-clockwise? It is what? Anti-clockwise. It's going to be what? Negative. Do you get that? So now let's go now. We are going to have 5 times 1 plus 8 times, what is the distance from here to here? Is 1 plus 1 plus 1, which is what? 3. Minus ROB times the total distance. ROB times the total distance, which is what? 4. You know, this our moment is moving what? Anti-clockwise, which will be what? Minus 25 equals to what? 0. So now I hope you can see this. 5 times 1 is what? 5. 8 times 3, I think 8 times 3 is still what? 24, plus 24 minus 4 ROB minus 25 equals to what? 0. So this plus this is 29. So we are going to have 29 minus 4 ROB minus 25 equals to what? 0. 29 minus 25 is nothing but what? 4. So which is 4. It's going to be 4 minus 4 ROB equals to what? 0. If this one crosses to the other side, it's going to be what? Positive. So it means 4 ROB is equals to what? 4. For me to get my ROB, I divide both sides by 4. So ROB be equals to what? 1 kilonewton. Do you get that? So now for me to get my ROA now, what will I do? I'll come back to my equation 1, which is ROA plus ROB, which is equals to what? Which is equals to 13. Which is equals to 13. So ROA will be equals to 13 minus ROB. So ROA will be equals to 13 minus 1. So ROA is equals to what? 12 kilonewton. So here ends the solution. Thanks.